Okay, so good afternoon, everyone. As mentioned, my name is Peretz Regev. I'm the head of engineering at the Global Risk Science in PayPal. Together with me.
Hi, I'm Uri Arad. I'm head of the risk analytics team at Global Risk Science.
And today we're going to talk about people and not numbers. And before talking about people, I want to show you some numbers around PayPal. As mentioned before, PayPal, whatever PayPal is doing is all around big data. So we have, just to give you some notions of the numbers that we are dealing with, we have more than 160 million active accounts. And I can tell you that we have many more, at least double than this number, of inactive accounts or other accounts such as guest accounts. And I'll talk about guest accounts later on. We have 2 billion different events logged in every day. When I'm talking about events, it can be log in, it can be change your profile, it can be add your credit card, or just change your bank account. Or, of course, a payment transaction is also an event. So everything that we do is dealing with big data. Now, here in Tel Aviv, many people ask me, do you have a PayPal office in Tel Aviv? And I can tell you that when I joined PayPal, many of my friends asked me, you're going to San Jose to work in PayPal? So I want to tell everyone that we have an office in Tel Aviv. And actually, the office in Tel Aviv has more than 150 people. We have the Center of Excellence for Risk Management for the global PayPal company here in Tel Aviv. And I want to tell you a few facts about what makes us very unique and what is our secret sauce in PayPal in Tel Aviv. So the first thing is that we have a very versatile team that is working together. This is why the presentation here is a joint presentation together with Uri. We have a bunch of developers, QA engineers, data scientists, data analysts that are working together in a very short cycles. And we always laugh about it that we have, every day we have a new startup working in PayPal. So very versatile team working together, co-located. The second secret sauce is the background. So half of our population have either master's degree or PhD. And we have a very unique process for identifying the talent that we want to have in PayPal. Technology. So Matan talked in the morning. We are one of the most early adopters of Hadoop. We started Hadoop, working with Hadoop like 3 to 4 years ago. And actually what we are doing is that we are in the very beginning of the big data discipline, we are there. And in cases where we see that there is a need for us to develop something, we will develop it. We'll have a very large amount of homegrown applications. And in some cases, we also go to the open source community, take what this community has to offer, and we also contribute back to this community. So this is kind of a very good combination. And the last one is about the methods that we are using. Any kind of slice and dice of the data, either it's a graph mining or text mining, and of course advanced machine learning, this is what we do in PayPal. And of course we'll dig in later on. So I want to introduce you, this is a use case track, so I want to introduce you only one of the use cases that we are dealing with. And actually it is a real story. So my friend Uri over here got his iPhone 6 last week. And Uri, I don't know if you know, probably not. I decided, me and Uri are working together for a long time. And I decided to buy him a phone case. And knowing Uri, I know that he is a fan of Van Gogh, and this is his very, very special avatar that he likes the most. So I found this combination in Society6, very known e-commerce site. And then I just, I found it very unique, and I click on the add to cart. Of course, I'm paying with PayPal. And, but then when this Windows popped up, I just realized that I forgot my credentials to PayPal, which happens to many of us every now and then. Now I had few alternatives. Of course, I can click on forget my password and get the password and get my ID back, but I really want to buy this thing right now. So the other option that I had is actually click on the other button over here below the login with PayPal, which is what we call buy as guest. And we can buy with PayPal as guest users with no credentials, with nothing. But what I realized that is when I used this buy as a guest, something was different in the experience that I had. And the difference was that in my previous purchases, when I logged in with PayPal, I got some special offers from PayPal. For example, I got some credit options to buy whatever I'm buying right now. And when I logged in as a guest, nothing was offered. And then I realized that PayPal doesn't know that this is me because I logged in as a guest. So actually, I asked myself, wouldn't it be great if we can really know that the person that logged in as a guest is really one of our very veteran customers, that I can really offer him a better experience? So I want to raise a question, and maybe you can help me. So I think that the issue over here is really to connect between two different accounts to the same person. So maybe someone has an idea of how can I connect two different accounts to the same person? The participation for the PayPal company is not allowed. Yes? Same IP, good. Okay. Any other?
Tracking cookies. What else? Same credit card. Same credit card, okay.
Billing address.
Billing address.
Good. Uri.
Other ideas? So first of all, Peretz, thank you.
Sure.
I didn't know that you're getting me this iPhone case, so I'm very excited about it. And I'll be looking forward to getting it. The phone is here, by the way, it's not a lie. No case. So everything you mentioned here are very good ideas, very good suggestions about some ways that we may be able to know that two accounts belong to the same person. And the reason that we care about knowing that two accounts belong to the same person is because we want to achieve accuracy. And we want to achieve accuracy especially when we talk about creating good experience for our good users. Now, this is not a problem that's unique to PayPal. In PayPal, we can understand that we have users may have multiple accounts, and Peretz, this just ran into one of the scenarios that generate a guest account and a registered account. But there are many other reasons why people may have multiple accounts. They may have multiple accounts because they forgot the password like Peretz. They may have multiple accounts because maybe they used PayPal, they didn't even know that they used PayPal in some cases, so they didn't even try to use the registered account. Some people have multiple accounts because of geographic reasons. So if you want to use and pay for Netflix, you have to have an American account. So even if I'm an Israeli, I will have to open an account. And if I'm a business, I may have to open an account because I want to do business in multiple currencies. So these are all reasons that people may have multiple accounts. Now the question of being able to identify all the accounts that belong to the same person, to the same business, and being able to assess them together is really what we're trying to achieve here. And just to give you an idea about some of the challenges, and I'm trying to take some of the ideas that were offered here in the audience and give you an idea why this is really a tough task. So first of all, the size of the task that we're talking about. Given the number of accounts and the amount of activity in our system, we're talking about potentially having to compare over 10 to the power of 17 pairs of accounts just to check whether they may be the same account. In some cases, there may be a very efficient way of doing it. So maybe if we have something like a cookie, maybe an easy comparison. But in other cases, that comparison may be very complicated to do. Then, people mentioned billing address as one of the options. Billing address is not as easy as you may think, because when someone types a billing address, we're all only human, right? We may use different languages, different characters, and we may have spelling mistakes. So even being able to know that two addresses are the same may be a challenge, because I may be living on the corner of, Main Street and 3rd Avenue. So I may have actually two different addresses that may look completely different, but may be the same address. And of course, if we're talking about names, then we also have the challenge of nicknames. So the machine doesn't know that Alex and Sasha is actually the same name, the same way that they wouldn't know that Richard and Dick is the same name. Last but not least, the reason that this challenge is also complicated is because beyond having to do all the comparing all the different pairs that we mentioned before, we want to find all the accounts that belong to the same user. And in order to do that, we want to look at all the events and all the data that we have on the account, and we want to apply that and to say not only that if we know that account A and B belong to the same person, if account B and C also belongs to the same person, we want to group them all together into one, what we call entity. So what's our approach to doing that? So this is a recipe of how PayPal wants to do linking, and how we go from looking at accounts to looking at real people and businesses. So the input to our recipes starts first of all from all of the accounts. And the accounts includes both registered accounts and also the guest accounts. We're talking about hundreds of millions of accounts. Some people don't even know that they have accounts in our system. Then for each account, we look at all the different properties that were mentioned. We looked at name, addresses, credit cards, bank information, every piece of property that we have about that account, and we're talking about billions of data elements. Last but not least, we're looking at all of the activity and events that we have on the system. So we're looking for cookies, we're looking for IPs, we're looking for behavioral elements in order to crunch all of that data together and being able to say, based on all of that activity, whether we can find any way that we can prove that account A and account B belong together. Now, once we have all of the ingredients, we get to the job of actually creating those elements. And this is where, again, what is unique about our approach is what we call the side-by-side approach. And again, part of the reason that Peretz and myself are here speaking together. So we have our analysts and data scientists working very closely with our technology and engineering group, because we know that everything that we build doesn't only have to work in the lab. It has to be something that we can apply at scale and repeatedly in PayPal. So we start by looking at it from an analytical perspective. And we're trying to ask ourselves, what is the definition of the entity that we want to find? Is it a person? Is it a business? It may be something else. Then we're starting to ask the same question that we asked you earlier. What type of logic we can use in order to define and say, based on the type of entity we want to find, how can we tell that two accounts belong to each other? So you mentioned something. Some of the logic you mentioned actually is very strong, but some of the logic may not be as strong. If we talk about using cookies, maybe I can have two different people using the same machine. If we talk about an IP, well, if Peretz and myself would log in from our corporate network, we are going to share an IP. Does it mean that we're the same person? I think not. Then, once we have that and we've refined the logic from an analytical perspective, we immediately go to implementation. So we will work with the technology group to make sure that the logic can be implemented, that it can be implemented in an efficient enough way, and that logic also holds from a statistical perspective, so that we can know that we have the right level of false positive and false negatives in order to apply that recursively. Because if we don't reach that level, if we don't know how to calculate that, then once we start to apply this logic recursively, our level of accuracy would drop shortly very quickly. And then last but not least, everything we do happens at scale and has to happen repeatedly, and we always have to serve our goods fresh. Because the next time that someone logs into PayPal, if if Peretz logs in next time, we want to know that we know Peretz. We want to be able to offer Peretz the credit offering, even if he didn't provide us the credentials. We want to give him the best possible experience, and for that, we need to be able to always have the most up-to-date linking maps as we can. So let's see this in a little bit of details, how that works, how this process works. So we start with an account, and we look at different ways that we can connect accounts, and we call them links, as we said. And some people may have mentioned earlier name, so that could be one type of link. And we can have different types of link, like the combination of a name with a machine, with a cookie. And then we can look at all different types of links, and these may spread the networks of accounts. Now, we're going to apply the logic that we've mentioned to define the different entity, and we're going to examine the strength of each of these links, and eventually be able to identify, for example, in this case, that account A is connected to all of these other accounts, and at the same time, account A may also be connected to a completely different set of accounts as a business account. As you can imagine, this is something that, these are just some examples, and a large part of the science and the investment is also coming up with additional logic and more complex logic than what you see here in order to achieve also the highest level of coverage that we can. As far as implementation goes, once we build this logic, we actually leverage a combination of real-time system and an offline system. And the goal is to make sure that we have the ability at the very tight SLAs, meaning at the time you log in, at the time that you try to perform a transaction, that we're able to connect you to the right entity in real time and give you the right treatment and be able to provide great customer experience. But at the same time, we know that this cannot be achieved in real time, and therefore we build a combination of an offline system and a real-time system. In the offline system, we're doing a lot of the heavy lifting and then provide the data to a real system that does augmentation of the result in real time. We're using a whole set of technologies. As Peretz mentions, we're also building a lot of homegrown technologies. You can see here something called the zone key. Does anyone know what the zone key is, by the way? Someone seems to know there. Do you want to tell us? Exactly. So a zone key is a hybrid of a zebra and a donkey. And this is a little bit of what we had to build here. Because the Hadoop platform is still not mature, we actually used a lot of off-the-shelf tools, and we combined them together into our own platform on which we build the application, which is called Zonki, and we keep developing that platform in order to be able to build other large-scale applications. So this is how we approach the problem of linking. This is how we solve it. And at this point, I'll pause and open the stage for questions if anyone wants to get a little bit more details. Yes? Mm-hmm. So, excellent question. That was actually one of the samples that I considered using, but I didn't know if it's politically correct. So thank you for bringing that up. So there's a difference between us knowing that both accounts belong to the same person and then giving you the best treatment that we can based on the history that we have on both accounts. And this is what we will do. What we will not do, we will not share the history. So you will never log into one of the accounts and all of a sudden see the account, the activity on the other account. So all of this happens behind the scene. We use it for our decisioning and logic, but it's not being exposed to the end user in a way that would compromise their privacy. Yes?
And what about faces? You could use faces as identifier of
Sorry, can you repeat the question? Face recognition. Oh, face recognition. So we're not doing face recognition yet. But of course, if we would have used the biometrics could have been another parameter to help us doing linking. I don't know how familiar you are with biometrics, but at least, I'm not an expert on biometrics, but at least most of the biometric solutions that I've seen are only applicable once you have an assertion of an identity. So if I assert that this is my account and you just want to validate it, then you can use biometric. And even in this case, I think on equal error rates, you would get to something like 92 to 96% accuracy. Obviously, if we talk about 10 to the power of 17 pairs, biometrics is going to give me a huge amount of false positives. Yes? So that's a great question, and it goes back to the point we made earlier about the fact that we need to, first of all, define what is the business purpose and what is the entity that we want to create. Based on that, we also define what type of error is important. So if I wanted to create an enablement solution, I would try not to have, I will be more towards missing, finding the two accounts belong to the same person, and I will try to make sure that I have a very low probability of mislinking. If I may have, for example, look for linking for detecting fraud, I may want to go the other way. So I might say, you know what, I might be more suspicious of an account that may be innocent, but prevent fraud from happening, versus going a conservative way and let fraud go into the system. So different applications may call for different type of linking and definitions. Any other questions? Okay, so thank you very much, everyone. It's been our pleasure to be here.